Okay, so we're back and we've got our values for all of this for the entire distribution. And what we see here is that we've got 0.2373, which we had 0.3955, and then for 2 is 0.2637. 0.2637. Wait a second here. That doesn't seem right, because when we did this before, we got 0.0264, and now we've got 0.2637. Why is that? We'll look at that in just a second. All right. Instead, here's what we're going to do real quick. We're going to graph this, okay? So let's graph this model that we have here for the values. And actually, if we go on one more page, I have the model right here. Here's the model with 0, 1, 2, 3, 4, 5. And we're going to create a graph of this model. So we'll go to the calculator and we'll go to stat plot. And we'll turn it on. And what we're going to do is make sure that we have a histogram, because we're going to plot this as a histogram. And we're going to put where our X list is, and my X list happens to be in L1. Now, your frequency from default here for frequency is 1. But our frequency is actually going to be the height, or those probabilities themselves. So our probability for 1, for example, is 0.3955. That's what I want for the height of those bars. So that happens to be in L2. Now, here's what happens. Let's zoom 9. Look what happens. Zoom 9, our favorite button in the whole world. It's a box. Whoosh. That means nothing. And why is it doing that? Because again, the calculator doesn't know that you like integers, and it just doesn't care. So its window is way off. Now, let's think about what's happening here. Here's my graph, and I have to go 0, 1, 2, 3, 4, and 5. And what I want is I want this first bar to go from 0 all the way up to but not including 1. And then from 1 up to but not including 2, and 2 up to but not including 3, and 3 up to but not including 4, and 4 up to but not including 5, and 5 up to but not including 6. Which means what I have to do is I have to set this X width or X window to go from 0 to 6. So I can do that. All right, so I can go to the window and I'll see what the window here is. 0, the window goes from 0 to 10. I don't need that 10 there. I need to go from 0 to 6. Okay, that's fine. What about my X scale? How far do I want these bars to be? I want these bars to be 1. So I'm going to make that 1. That's fine. That's all set. Okay, now let's talk about the Y part of this. My maximum height right here is 0.3955 or 0.4. I want to see that, and I want it to be as big as possible. But I also want to make sure that I see the top of that. So what I'm going to do is I'm going to set this Y maximum here just to be a little bit above that. I'm going to set my Y max to be 0.5. And consequently, I want to see, I want to see the X-axis. I don't want it to be down here at the bottom. I actually want to see that. So I'm going to set my Y min for negative 0.1. And what do I want my scale to be? I want my scale to be where those tick marks are going to be on there. And 0.1, because we always think in tenths, 0.1 is groovy. So we're going to hit graph, and there it is. Okay, what's the shape of that distribution? Skewed right. Okay, so there we are. There is our distribution, and we had 0.2373, 0.3955, basically 0.4 at that mark right there, 0.2637, 0.0879, 0.0146, and 0.0010, which you can't see really, but notice that it's still there because there's the width of that bar right there. We're fine. Okay, that's great. So that is the probability distribution PDF graph. All right, so what is the other graph that we had? Well, the other graph that we actually talked about, or I should say the other graph we haven't talked about, but the other one that is there is this. Oh, maybe it's over here. Here we are, is the CDF distribution, which means it calculates and sums as it goes, up to X. So let's do that graph right here. But let's talk about what it's going to do. Let's go back to this model here and say, okay, so it's going to sum as it goes. So I'm going to start at 0, and I'm going to have a probability of 0. Then I'm going to sum as I go, which means that I get the probability of 1, I'm going to take these two values and I'm going to add them together. And what this is going to be, this is the probability is going to be, you can get 0 or 1 kid with type O blood. So it's an or statement. An or means add, which means or I'm going to add these two together and I'm going to get that. Then, when I get to 2, it's going to be the probability of 0 or 1 or 2, so I would add these probabilities together, but really I'm going to take the sum of these two and just add this third one on. That's what's going to happen. So, let's go to the calculator, let's go to stat, let's go to edit, let's go to L3, and in L3, let's go up here to the menu, let's do the binomial CDF. So we'll go to distribution again, well this time we'll find binomial CDF, NPR, same values, 5 kids, probability 0.25, comma, and then where's R? R again is L1. There's the successes right there. They should match up. We're going to hit enter, and notice I get 0.2373 for my first one, and my second one is 0.6328, which is going to be these two values, these top two values, 0 and 1, added together. Okay, super duper cool. So, actually, we have these values listed right here. So here is the PDF, here is the CDF, 0.2373 for 0.3955, the probability of exactly. Here is a probability that x is less than or equal to 1, meaning it could be 0 or it could be 1, 0.6328, these two values added together. Probability of 2, PDF, exactly 2.2637. Less than or equal to 2, it could be 0, it could be 1, or it could be 2. These three values added together. So, without looking at it, what would the graph look like? Thinking about what the sum is going to be. And first, even before we get there, what's the last bar going to be if I'm going to sum, if I'm going to sum as I'm going to go? The last bar is going to be, pause it if you're thinking, if not, jump right in. Hey, look, it's 1. So that probability is 1. So what is the shape of this graph going to be? Well, if this last bar is 1 and this first bar is not, and it's going to increase until you get to 1, it should be skewed right. So we could graph that by going to stat plot, plot 1. Okay, x-axis is plot 1, or is list 1. Frequency list is going to be in L3. Now, keep in mind that because my highest bar was set at 0.4, my newest highest bar is set at 1. What I actually have to do is I have to go change the window, change the Y max to, my Y max is going to have to be 1.1, so I see that entire thing there, 1.1. And we'll just graph it, and there it is. It is skewed to the right. Or sorry, skewed to the left, skewed to the left. And there it is. There's the very first bar. There's the first bar and the second bar of the PDF added together. There's the first bar and the second bar and the third bar of the PDF added together. And here they are side by side in comparison. Here's the PDF, here's the CDF. First 2 bars added together, first 3 bars added together, first 4 bars added together. That little difference right there is that right there. And this one is basically 0, so it's added on. So then we can ask ourselves this question. We can say, okay, this is skewed left, and it's always going to be skewed left, always, 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 except when it's not. And what's the one time that it's not? And in order to answer this question, realistically, we need to ask ourselves, okay, what shape can it be? If it's not skewed left, what's this graph going to look like? And thinking, can this graph be skewed right? No, not if I'm going to sum as I'm going to go, because it's not going to decrease. Can it be normal? No, because if I'm going to sum as I'm going to go, I can't have it decrease. So what shape does this have to take on? It has to be uniform. It has to be a rectangle. Okay, so if it's going to be uniform, it's going to be a rectangle. And this last bar is going to be 1. What does the first bar have to be? And the answer is the first bar has to be 1. So the probability of having 0 has to be 1, which means all of these other bars are going to be 0, but because it's cumulative, it's going to stay exactly as it is, and it's going to be uniform in shape. All right, coming back after the break.